Welcome everybody. The question is whether left-handed and right-handed and chirality is the same. So, I will think that chirality is the property of being in two states, left-handed and right-handed. So, a chiral object can have that form. Achiral or non-chiral. So, a two-dimensional example, suppose the swastik, our popular swastik. So, you can draw it like this or you can draw it like this, and there is no way by rotation in plane you can superimpose, although both of them look like very similar, but one can be called left handed. That is your choice, really left handed, right handed is from human hand, because human hand also have two versions. So, our left hand and right hand both appear very similar, but they cannot be superimposed in 3 dimensions. You can say that I am superimposing like this, but that is a 2-dimensional superimposition and is not really a superimposition, because top of the left hand is pointing top, whereas top of the right hand is pointing down. So, even if I am able to, if I am some sort of a supernatural ability and I superimpose on them in the same space, still they will not coincide, because the top surface of this hand and the top surface of this hand will not match. So, we have a left hand and a right hand looking very identical, very similar, but still not superimposable by rotation. So, that is the criterion. So, by in this 2D example you can't, again by rotation in 2D you cannot superimpose, but circle has no such problem. There is a known left handed or right handed version of circle in 2D, or a rectangle does not have this problem, or a square does not have this problem. So, why is it that swastik has this problem, but these are not having, or you call it problem or property? Why does swastik has this property of being in two versions, but there are no two versions of a square? Why don't we have a left handed and a right handed square? But a rectangle also does not have left handed and right handed. So, that only has two-fold. So, four-fold or two-fold is not really the distinguishing thing. And if you see, look, if I draw swastik, I have not drawn it very nicely, but if I draw swastik properly, it also has four-fold symmetry. So, square has four-fold symmetry, swastik has four-fold symmetry, but swastik is chiral, a square is not chiral. Due to reflection. So, if any object possesses a reflection symmetry, if it possesses a mirror plane, so all these objects which I drew as achiral have some mirror planes. circle has infinitely many mirror planes. I have drawn one of them. Rectangle will have two mirror planes, vertical and horizontal. A square has four mirror planes. So that's what distinguishes. If an object has a mirror plane, then if you reflect it, the reflected version will be identical or will be superimposable by rotation to the original version. Whichever mirror you reflect in, that does not matter. One mirror is sufficient. And if it has a mirror, you don't have to reflect it in the symmetry mirror plane, but any other mirror plane also if you reflect, it will move. That will not be a symmetry operation because it will not be a self coincidence, but still it will not change its chirality because you can bring the moved object to the original object by translation or rotation. I think this is the distinction between chiral and achiral object. So here we are seeing some examples. I think we have I had given you this classification, that proper or type 1 where there is no change in handedness. So that, see, that's why if it possesses only, so from here also you can see, if the object possesses only type 1 symmetry operations, then if you apply a type 2, it will become a different handed object. But if it already possesses an improper type 2, then it will not change because it has to have, if it is having a reflection or a mirror plane, this one has no type 2. Means if it is indistinguishable, then it's really not a left handed, because then what is the distinction between left handed and right handed? So then you will define, maybe you will define your left handed and right handed, that if I apply an improper operation, we get from left handed to right handed. You have to say that as your definition of left handed and right handed. And if on application of such operation the left handed and right handed version are not distinguishable, then it is achiral. You can say that, but yeah, I mean the difficulty or the only slight objection to that is that if the two versions are not distinguishable, then how do you say that one is left handed and one is right handed? Means you can say that circles left handed and right handed versions are the same, but then I don't know, how do you say that which circle is left handed or which? Whereas in the case of swastik, you can clearly identify two things which are not superimposable. We may still disagree which one is left and which one is right, but we have to agree that there are two types. So what I said here, change in handedness maybe needs to be little bit modified. It will change the handedness if the object itself is chiral, because we are seeing that it's not able to change the handedness here if the object was achiral. So can change handedness. So yeah, a direct claim, as I was making previously, that improper will change handedness was not perfectly right, because it cannot change handedness if the object is chiral, because it doesn't have hand. So how can you change the handedness? So whereas in the swastik case, So, see if I have a, now I copy and paste it, so it is identical swastik, and if I rotate this like this, I have not changed the handedness, it is just a rotation, because I can rotate this also. So, if I try to rotate this here, I can rotate and bring it in the similar position, and I think it got little bit changed in size also in my operation, otherwise I could have totally bring it into self coincidence. So, it is self coincident. That flip horizontal or flip vertical, they say, that is a reflection operation. So, I draw like this. Here if I now try to reflect it, suppose this is a mirror plane, now there is no way I can coincide it, it is not coinciding. It is not coinciding. If you think that by rotation it should be possible, that is also not true. There is no way you can rotate it and make it coincide. However much I rotate, I cannot coincide. But if I reflect it, I can coincide it. So, you can imagine reflecting it, then it will reflect like this, and then you can see that this and this are translatable. So, reflection is changing handedness. So, this is, if you call it left handed, this is right handed, and this is right handed. So, rotation did not change the handedness, but reflection changed.
Is reflection the symmetry operation in this case?
No.
So when you change the definition that a symmetry operation that change handedness, I mean anything that change handedness, can it be a symmetry operation?
That's a good question. So, the definition of symmetry is little bit extended to include that, by saying that if so, I cannot coincide left handed and right handed by translation or rotation, but I can coincide them. So, this left handed object will coincide with this right handed object by the reflection in this plane. Okay. So, if I have both this swastik, so the pair of swastik, which now becomes again achiral, because you have both left handed and right handed part. So, for that pair of swastik, this will be a mirror plane and will be symmetry operation. But yeah, so for the whole object, you can say that if I consider the pair, then the pair does not have handedness because it has a mirror, but part of it which is reflected changes handedness. Okay. So, maybe there is a issue there, I can see your problem. You can say that it is a symmetry operation of the object, but when applied to a chiral object it will change its handedness. The same operation when applied to a chiral object can change the handedness. Okay. But the object for which this is a symmetry operation will not have the handedness, because it will create the left handed and right handed part. So, yeah, for chiral it cannot be a symmetry operation, and for achiral it can be a symmetry operation, but that achiral object will have internally a left handed and a right handed part, which will be being interchanged by this symmetry operation. So little bit care is required